Do I have to enlarge it a little bit here? Yeah, I can say this diagram. I suggest you will include how to describe the source or the sink, right?
Yeah.
And also if you do, it does have the mathematically, because this is mathematical, right? If you have
Yeah.
the curve, if the curve is not zero, that implies there's kind of the what you call vorticity, right? Vorticity,
Yeah.
can you see? So, and this can you see the omega here, right? It's just
Hmm.
like it's just exactly like you read the uh, uh, weatherman weatherman weather forecast. You see that
Yeah.
patterns that sometimes you see the vorticity, right? So
Okay.
that gives people ideas that how to serious researchers, to describe how to describe this fluid dynamics. So the keyword is a computational fluid dynamics. Okay,
Okay.
so to don't go too far away from this concept. So on the one hand, you will got a computational detail here in this way,
Mm.
say, right? On the other hand, you do transform or you get a description of various dynamical phenomena, right? And
Okay.
also, importantly, in both cases, you will calculate that the pressure drops that will be
Yeah.
relevant to the clinical diagnostics. And
Yeah.
this,
Okay.
so yeah, why don't you put this diagram here? How to write the continuous function into the discrete form? Okay,
Yeah.
that's important. Use discrete form, and more importantly is we have to go to the. Oh yes, you can still talk about. Yeah, if you wish, why don't you look at this summary here? I think some of them are relevant to your writing.
Yeah. I don't think I've got all of this.
Yeah.
I've only got
Oh,
a few snapshots. Can you send me?
I can send it to you. Yeah. Can you see? Oh, that is the Moody diagram here, right?
Yeah.
And so that is independent approach. Yes, I can send that to you. Yes. Yep. I can send it to you. You can have summary. Yeah. So that's my suggestions. Uh, yes. How's your? And also, it's hard. You can select some of your diagram when you prepare the draft after this
Okay.
lesson. I suggest you also prepare some the typical diagram,
Yeah.
not just for deviation purpose, but also for your calculating part, like
Yeah.
your
Okay.
simulated time dependent pattern. That's been looks very good with
Hmm.
this. So don't spend too much time to put the English word at this stage.
Okay. Yeah.
So like this one, can you see? I think some of them I sent it to you already, right? So for example,
Yeah.
so you
But I
have to
haven't got any of that. I don't think.
yes, how to, for example, how I will cut into smaller because this is a huge file. I will cut into small uh, A4 form. I will reform that for you. Okay. So these are what I expect to see next time. That at
Yeah.
least you have to tell people how actually you solve it. It's amazing. Yeah,
Okay.
it's
Yeah.
it's amazing to be able to solve the equation which has been considered one of the, if not the one, but actually the most difficult differential equation model in physics, right?
Yeah.
Because otherwise, if you Maxwell equation is relatively easier because it's just dealing with uh, dealing with charge and current, right?
Yeah.
But anyhow, I think that's what. Yeah. So we agree. So after a few days or after 1 week, you will send me a draft in a Word form, okay,
Yeah.
which contain your main. I hope complete sequences of mathematical formulas. That's
Yeah.
your explanation.
So don't worry
And
about the writing part. Just get down the
no, not the
maths.
writing part, but you have put in proper subtitle in the sections, right? For example,
Yeah.
for this section, I'm doing this section doing that. That is the most important part. I wish to see the skeleton and then we will decide how many words we can put there to explain.
Well, I'll have to submit my draft in like then I've got 2 weeks.
In 2 weeks' time, yes, we should have time. We should have time. Yeah, we should have time. Why don't you, in 2 weeks' time, why don't you just spend 1 week to prepare these formula sequences together with not too many, probably just 2 or 3 of your key results.
Okay.
Simulation, okay? And
Yeah.
not big, yeah, and then in 2 weeks' time, we should see a proper first draft.
Yeah, okay, got it.
Yeah. I think that's yeah, I think we have some. Yes, deviation. Yeah, I think you have to tell people that some detail about, as we discussed. I think I have another diagram here, which is discretization. Yeah, that's one. A little bit of snow. Here.
Yeah.
So that other than that, so after you derived the vector form, then you just expand it again. But this time, the objective is to rewrite that differential equation into the algebra, the difference equation, right?
Yeah.
So that is something I wish to see in your next draft, right?
Okay.
Because that will tell people how to deal with first derivative, how to deal with the second derivative.
Yeah. Can you send this document as well?
Yes, I will select some for you. This is let's just reduce that. This is not very big. This is not very big. Yeah. Yes. Okay. I'll prepare some for you. Okay. I will put some relevant. Yeah. Like this one. Okay. This diagram you can. There is a narrowing here. Can you see there is a narrowing here, and so you will see the pressure drops for sure. So that is what you need to know. I think the highlight of this essay will be that your simulation. I still, because when I last time saw your result, right? That's the most impressive pictures you can include into this essay.
Yeah.
And yeah, don't discuss everything. Just show that here is this is the most fundamental equations for CFD, and here is how to actually calculate for the given assumptions. That is the key, the main point here. So it is mathematics. Any other questions?
No, I think I'll go over this again and then see how it goes.
Now this time you don't have much time, so don't just go back to that format, okay? If you don't like the structure, change it, right? If you want to delete some section by replace something by something else, that's fine. That's fine. But you don't jump to the this kind of magnifying glass. You just go to detail, and you don't have too much time now.
So then for my derivations then, do I just derive the Navier-Stokes equations?
Confirm you that, yeah, that's right. Not the first continuity, just the second momentum, right? Okay. And also don't spend time to derive the Bernoulli equation. It is simple. High school kids can understand that.
Yeah, okay.
So that is what my suggestion. So that's probably pretty what occurred to me at the moment.
Yeah.
Okay. So really, I expect to see some what we call the first draft. That should include the sequences of the formulas, right?
Yeah.
Not just theoretical discussing that this is concept, this is the density, this is what. No, I want to see the full pictures, right? From the notation, from the draw and the curve notation, gradients notation, to the for the equation you used in your simulation, right? That difference equations.
Okay. Got it. That's fine.
Okay, shall we stop here today?
Yeah, I think that was good.
Okay. Okay. So tomorrow I will prepare some. I'm a little bit tired now. I will prepare some. I will select some equation for you from that
Okay.
large files. Okay,
Okay.
goodbye.
Thank you. Bye.
You're welcome.